In a remote galaxy, years away, a star 100 times more massive. For a brief moment, it will unleash more energy than it combined, sending shockwaves across space-time itself. Tonight, we journey through cosmic forces so extreme reality to their will. We will visit explosions at galaxies, black holes that devour light itself, forces that hold the very fabric of existence together. Prepare a voyage into power beyond imagination. We begin. Deep inside every atom in your body, visible war is raging. Protons packed together and tear themselves apart instantly. Their positive charges repel each other, like trying to push two powerful magnets together. How? They remain locked in place by the strongest force in the universe. The strong nuclear force operates at distances smaller than a single proton, but its power is absolute. Scientists measure it times stronger than electromagnetism, and 100 trillion times stronger than gravity. Think of it this way: if gravity were a whisper, the strong force would be a thunderclap. This force works through particles which act like invisible chains binding quarks together to form protons. The more you try to pull these particles apart, the stronger. It is like stretching a rubber band that grows thicker with every inch you pull. This bizarre behavior confinement means you can never isolate a single quark, how much energy you apply. Inside each proton dance in a prison of pure energy. The gluons that bind them carry itself, creating a web of interactions so complex, powerful supercomputers struggle to model them. When you try to, the energy you add simply creates new quarks and gluons, trying to cut a chain only to have it grow new links. This rates on scales so small that a femtometer seems vast. That is 1/4,000,000th of a meter, smaller than imagined. At these distances, the familiar world breaks down completely. Space and time themselves fluctuating according to the strange rules of quantum mechanics. This force shapes the very building blocks of matter. It determines which exist and which cannot. It sets the rate at which stars burn their nuclei. It controls the balance between creation and destruction in the heart across the cosmic void. Without the strong force, it would instantly fly apart due to electromagnetic repulsion, not form. Fusion reactions in stellar cores would never begin. Contain nothing but hydrogen atoms and free electrons, yet despite its incredible strong force has a fatal weakness. Its reach extends only like nucleus, about 1/10 trillionth the width of a human hair, microscopic realm. Other powers take control, wider universe, where distance means everything, and witness what heat and light collide in the most violent explosions ever detected. In the cosmos, a beam of pure energy tears through space for just 10 seconds. It releases more power than its entire 10 billion year lifetime. This is a gamma ray burst, represents the most powerful explosion the universe can create. These occur when the most massive stars in existence collapse into black holes. We are talking about stellar giants containing the mass of 20 to 100 suns, through their nuclear fuel at a rate that would consume our sun's entire energy a few million years. When these monsters finally exhaust their fusion, gravity wins the ultimate battle. As the star's core implodes, jets of matter and energy from its poles at 99% the speed of light. The collapsing core creates a newborn black hole, surrounded by a disk material. Magnetic fields, twisted and amplified by the cosmic cannons, launching these jets outward with impossible precision, punch through the dying star like bullets through tissue paper, emerging a structure that remain tightly collimated across vast distances. That maintains its focus while traveling from Earth to the nearest star. Accomplish something similar on scales millions of times larger. A burst can outshine 1,000,000,000,000 stars. If you could see gamma rays, these explosions would appear brighter than the full moon, these billions of light years away. The energy released in seconds, 1,000,000,000,000 hydrogen bombs could produce if they exploded every second for the universe. The most powerful gamma ray burst ever detected, the boat, the brightest of all time, occurred in October 20. It was so intense that it saturated gamma ray detectors across the solar system, created detectable changes in Earth's upper atmosphere from a distance of 2 billion. Picture standing on Earth and watching a flashlight beam from Alpha Centauri as bright as a car headlight. That gives you a sense of how impossible events truly are. The light we detect traveled for billions of years. News of stellar deaths from when the universe was young and stars were more than anything we see today. Scientists have detected bursts, so their light began traveling when the first stars were being born, less than one Big Bang. These ancient beacons give us glimpses of the early cosmos. Massive stars lived fast and died violently, seeding space with heavy for later generations of stars and planets. But compared to what lurks in galaxies, even these titans pale in comparison. Galaxies, it's a monster 4 million times more massive than the Sun. Sirius A-star devours everything that ventures too close, from gas clouds to stars. Yet this giant is considered small compared to the true deep. Some supermassive black holes contain the mass of suns, compressed into a region smaller than our solar system, like cosmic vacuum cleaners, with gravity so intense that nothing can escape once it crosses their event horizon, and time bend around them like water swirling down a drain, distortions that would seem impossible if we did not observe them directly. Gravitational monsters did not grow slowly. The most distant quasar's universe was less than 1 billion years old, powered by black holes, billions of solar masses, in the cosmic equivalent of a few minutes. Achieved such impossible growth remains one of astronomy's greatest. Normal stellar evolution simply cannot explain. The leading theory suggests these giants began as massive seeds of collapsing gas clouds in the early universe. Unlike stellar mass formed from dying stars, these primordial monsters may have contained hundreds of masses from the moment of their birth. This head start allowed them to grow, consuming surrounding matter and merging with other black holes. With a supermassive black hole, friction heats it to temperatures of millions of degrees. The material forms an accretion disk that glows brighter than 100 billion. The disk rotates so rapidly that matter near the inner edge travels at significant speed, experiencing time dilation effects that would stretch seconds into hours. The most luminous quasars, powered by feeding black holes, is the observable universe, like cosmic lighthouses broadcasting their presence of light years. They outshine their entire host galaxies, and light of hundreds of billions of stars seem dim by comparison. Black holes launch jets of particles at nearly light speed, creating for hundreds of thousands of light years. These jets carry enough entire galaxies, heating gas clouds to millions of degrees, from forming across vast regions of space. The jets can millions of years, continuously pumping energy into their surroundings. And observations have revealed black holes that seem too massive for their host galaxy. The normal relationships between central black hole mass and galactic properties. Massive giants challenge our understanding of how galaxies and their central black together. But even these titans bow to forces that operate on nation. Across 13.8 billion light-years of space, force is winning a cosmic war. Every second, he's farther apart, stretching the very fabric of space-time. It's this mysterious power, called dark energy, percent of everything that exists. Yet we know almost nothing about what. Dark energy is not like other forces. A distance, like gravity or electromagnetism. As space expands, more dark energy appears. The bigger the universe becomes, the faster it expands. A cosmic gas pedal that only knows how to accelerate, growing strong everything apart. Scientists discovered this force by accident in supernovae in the 1990s. They expected the universe is going down due to the gravitational pull of all the matter within it. They found the opposite. Space is expanding faster today than years ago, as if some invisible hand is pulling everything apart with increasing. Think of the universe as a balloon being inflated by an invisible breath. Energy is that breath, causing every point on the balloon's surface away from every other point. Galaxies ride this expanding, swelling ocean, powerless to resist the tide that carries them into the cosmic. The amount of dark energy in the universe increases as space expands. This seems to violate conservation of energy, one of the most fundamental. Yet observations consistently show that the energy density remains constant, even as the volume of space grows. Where energy comes from remains completely unknown. Current dark energy might be a property of space itself, a kind of cosmic that Einstein originally proposed and later called his greatest blunder. I think it could be a dynamic field that changes over time, or even evidence gravity needs major revision on cosmic scales. The consequences are profound and terrifying. In the far future, everything we see. First, galaxy clusters will separate, becoming isolated islands in an ocean of expanding darkness. Then, individual galaxies will lose their ability to hold together expansion. Eventually, even atoms themselves may be stretched apart, all the Big Rip. Stars will be extinguished, planets will drift away, and even the fundamental particles that make up matter will be separated by vast. Dark energy, which seems gentle today, will become the destroyer, unmaking everything that gravity and the other forces worked billions. Imagine taking a mountain and compressing it down a sugar cube. The result would still be 1,000 times less dense. These cosmic lighthouses pack the mass of our sun into a miles wide, creating gravitational fields so intense they warp and bend space-time into impossible geometries. But terrifying feature. Neutron stars possess magnetic field times stronger than Earth's protective magnetosphere. These trap charged particles and accelerate them to nearly the speed of light, creation that sweep across space like cosmic searchlights powered by the fundamental universe. The magnetic field of a typical neutron star is so powerful every credit card on Earth from a distance of 600 miles. If you within 1,000 kilometers, the magnetic force would be strong enough to pull the field lines themselves become visible as they trap and channel streams into narrow beams. When these magnetized neutron stars become pulsars, firing beams of radio waves and X-rays with atomic clocks. Some rotate 600 times per second, faster, yet maintain perfect timing that rivals the most accurate timepieces. Each pulse marks another rotation of a stellar corpse spinning in the darkness. The surface of a neutron star is a realm of impossible physics that cannot exist. The magnetic field is so strong, it into needle-like shapes, aligned with the field lines. Atomic structure breaks down completely, replaced by that exist nowhere else in the universe. Any ordinary matter of a neutron star's surface would be compressed instantly into a layer. The gravity is so intense that a marshmallow dropped from waist height is with the force of a hydrogen bomb, releasing more energy than all the explode tube. Some neutron stars, called magnetars, have magnetic times stronger still, approaching the maximum strength allowed by. When these objects experience magnetic quakes, their crusts crack, releasing more energy in 1/10 of a second than our sun produces in 100. These magnetic cataclysms create giant flares that can be detected. The most powerful magnetar flare ever recorded tempered Earth's upper atmosphere from a distance of 50,000 light-years, double reach of these stellar remnants. The magnetic field around a magnet tense that it affects the vacuum of space itself, causing it to become crystal. Light waves become polarized as they pass through this magnet, providing astronomers with direct evidence of field strengths that exceed anything achieved in laboratories. But these stellar remnants are only the beginning of nature creations. Stretching across the observable universe are sliced through planets like wire through cheese. These cosmic superdists are one-dimensional objects thinner than a proton but potentially clusters. They are scars left over from the birth of the universe that phase transitions in the fundamental structure of spacetime. According to cosmic strings formed during the first fraction of a second, when the universe underwent rapid changes in its fundamental. They are like cracks in a frozen pond, marking the boundaries where diffs crystallized in slightly different ways as the cosmos cooled from a perfect symmetry. A cosmic string just 1 meter long would weigh as. Yet these objects are so thin, they are essentially one-dimensional, having length but no width or height in the conventional sense. Exist at the very boundary between existence and nothingness, matter, energy, and pure mathematics made manifest. The energy contained within it is almost incomprehensible. A string, from Earth to the Moon, would contain enough mass energy to power human trillions of years. Yet this enormous energy is concentrated so thin that it has no measurable thickness, making cosmic expression of energy density. If cosmic strings move through space, they create ripples in space-time itself, generating gravity to be detected by our most sensitive instruments. These waves would have different from those produced by black hole mergers or neutron stars, allowing scientists to potentially confirm the existence of these theoretical objects. Cosmic strings intersect. They can create loops that oscillate like by the hand of the universe itself. But instead of producing sound waves, vibrating loops generate distortions in the fabric of reality, waves rippling outward at the speed of light. These cosmic strings lose energy through gravitational wave radiation, shrinking over time to disappear. A loop the size of our solar system would radiate away a few million years, vanishing in a final burst of space-time distortion. Some scientists believe cosmic strings could act as cosmic highways, a light travel through folded space. If 2 points in space were connecting, you could theoretically travel along the string and arrive at your light traveling through normal space. This would make cosmic strings the universe. Others think cosmic strings might be windows into our three-dimensional world. The strings could be fundamental objects that dimensional space, with only their one-dimensional cross-sections visible in our. These theoretical monsters remain hidden in the mathematics of physics, heard or disproven by future observations. 4 billion light-years, a black hole the size of our solar system is launching a beam of particles an entire galaxy. This jet of superheated plasma, 99.9% the speed of light, carry to power 1 trillion stars while maintaining perfect focus distances that dwarf human comprehension. Quasar jets are surrounding supermassive black holes, where spacetime itself between gravity and magnetism. As matter spirals inward, it forms an accretion disk, spinning at incredible velocities, amplified by the disk's rotation, become twisted into configurations with amounts of energy. These magnetic field lines act like cosmic waves, channeling material from the inner regions of the accretion disk that shoot outward from the black hole's poles. The same gravity that should drag everything into oblivion instead launch some material back at relativistic speeds through this magnetic catapult mechanism. The jets, they appear drawn with a cosmic ruler held by divine hands. They focus across distances of hundreds of thousands of light years, threading through no human technology could match. The collimation is so perfect, observed with radio telescopes appear as thin lines, even winds of light years away. The particles within these jets carry energies greater than anything we can create in our most powerful particle accelerators. Individual protons race along the jet at speeds so close to light, mass increases by factors of thousands, turning ordinary matter into incredible power. When a quasar jet points directly at Earth, and the light appears to brighten and fade as the beams lighthouse. These blazars can vary in brightness by factors of days or hours, as turbulence in the jet creates bright knots of emission at apparent speeds faster than light itself. This faster than is an illusion created by the geometry of observation. When 99% light speed travels almost directly toward us, it appears distances in impossibly short times. The effect demonstrates the ultimate speed limit these cosmic jets actually travel. The most jets carry enough energy to heat entire galaxy clusters and the surrounding gas that persist for hundreds of millions of years. Cosmic blowtorches can prevent new stars from forming across regions of light years, effectively sterilizing vast volumes of space. Observations have revealed jets that extend far beyond their host galaxies to the intergalactic medium, where they continue to propagate for millions of years. Ancient jets carry the signature of black hole activity from cosmic epoch. The universe was younger and more violent than today. In a binary star seen light years away, a white dwarf star is slowly stealing companion like a cosmic vampire feeding on stellar blood. Hydrogen gas flows from the larger star onto the compact, building up layer by layer like snow accumulating on a mountainside. Snowball is approaching a deadly threshold that will trigger one of the universe's explosions. White dwarf stars are the dense cores left. Sun-like stars exhaust their nuclear fuel and shed their outer layers. Remnants pack the mass of our sun into a sphere the size of Earth, creating that a teaspoon would weigh as much as a car. Their surfaces burn at temperatures of degrees, hot enough to vaporize any known material. It accumulates on the white dwarf surface, compressed by gravity into a engine that gradually builds up pressure and temperature. The white cosmic pressure cooker, slowly heating this stolen matter until nuclear smolder in the surface layers. When the white dwarf reaches exactly 4 times the mass of our sun, something catastrophic happens. Critical mass, known as the Chandrasekhar limit, represents the maximum weight energy pressure can support. Beyond this point, the star can move up against its own gravity. The accumulated material ignites a nuclear explosion that tears the entire star apart in seconds. Fusion propagates through the white dwarf like a flame front, racing light, converting carbon and oxygen nuclei into iron and explosive nuclear fusion. The star literally burns itself. This is a Type Ia supernova, and it represents precisely violent events in the universe. Every Type Ia supernova almost exactly the same amount of energy, because they all involve the same mass undergoing the same nuclear reaction. This cosmic standardization tools for measuring distances across billions of light years shines with the light of 5 billion suns, visible from light years away. For weeks, a single exploding white dwarf entire galaxy containing hundreds of billions of normal stars, and then fades over months as radioactive elements created and release their energy. The explosion synthesizes and scatters for life across vast regions of space. The calcium iron in your blood and the nickel in coins were all forged in the hearts of exploders. You are literally made of stellar ashes scattered by these billions of years ago. The shock wave from a Type Ia supernova at thousands of miles per second, heating surrounding gas to tens of degrees. The explosion can trigger new waves of star formation clouds, while simultaneously enriching them with heavy elements necessary for formation. 2 city-sized objects spiral toward each other through the dark, locked in a gravitational death dance that has lasted for millions of years. They are neutron stars. The crushed cores of massive stars create the most violent event in the nearby universe, while forging less than anything in a king's treasury. Each neutron star contains the sun compressed into a sphere just 12 miles across. Their surfaces nuclei crushed together so tightly that a single teaspoon would waste on Earth. These are not ordinary objects, but rather the density that can exist without collapsing into black holes. As they closer, the neutron stars distort each other's shapes through pure gravitation. Tidal forces stretch and squeeze these incredibly dense objects generating heat that makes their surfaces glow with temperatures of millions of degrees. The orbital dance accelerates as energy bleeds away through gravity. These gravitational waves carry away orbital energy at an ever causing the neutron stars to spiral inward faster and faster. Themselves are ripples in space-time, stretching and compressing the very as they race outward at light speed. Advanced detectors on Earth, even though they change distances by less than 1/10,000th the width. In the final seconds before collision, the neutron stars complete a second, whirling around each other faster than a helicopter blade. The waves they generate become so powerful, they carry away the energy of these sun masses in just the last few seconds before impact, causing the death spiral to accelerate exponentially. When the neutrons, they create a brief flash of gamma rays, followed by a longer-lived supernova. The collision is so violent, it literally shakes the unending gravitational wave signals that can be detected from billions of light years away with instruments designed to measure the impossible. The merger forges heavier than iron through a process called rapid neutron cap. In the extreme conditions of the collision, atomic nuclei are bombarded with that they can barely absorb them fast enough. This creates neutron-rich isotopes that decay into stable heavy elements, including gold, uranium. A single neutron star merger produces quantities of gold, several Earth masses, along with comparable amounts of other precious metals. Collision ejects this stellar treasure at speeds approaching one-third the seeding nearby space with materials that will eventually find their way into planets and asteroids. The collision ejects material in moving at different speeds. The fastest moving debris creates the burst, while slower material forms expanding shells that glow with radiation for weeks afterward. This kilonova light comes from billions of new nuclei undergoing radioactive decay, creating a fireball that light of hundreds of millions of suns. 13.8 billion. Everything that exists today was compressed into a point smaller than a proton. All the matter and energy in the observable universe, from the smallest to the largest galaxy clusters, occupied a space with. This was the Big Bang singularity, and it represents the cosmic power, the moment when existence itself began. Primordial moment. The laws of physics, as we understand them, break down. Temperature and density become infinite. Space and time. The four fundamental forces that govern everything in the modern universe into a single, unimaginably powerful interaction that held itself. In the first fraction of a second, smaller than to cross a proton, the universe expanded faster than light itself. A period of cosmic inflation stretched space by factors of billions time than it takes to blink. Space did not explode into pre-existing, it created new space as it grew, carrying matter and energy along. The temperature during these first moments was so high that even of nature could not maintain their separate identities. Gravity, magnetism, and the strong and weak nuclear forces were indistinguishable. Single superforce that has never existed since those first instants of creation. As the universe expanded and cooled, this cosmic unity shattered quickly. The forces separated in a series of phase transitions, enormous amounts of energy, and determined the basic structure of physical law. Gravity separated, then the strong force, and electromagnetism split from the weak force. Minute after the Big Bang, the universe cooled enough for the first atom formed through a process called Big Bang nucleosynthesis. Protons, newly formed from cooling quarks, fused together in a cosmic forge the hydrogen and helium we see today. The energy density was so extreme antimatter annihilated each other in constant flashes of pure energy. 300,000 years after the initial explosion, the universe remained open. Free electrons scattered photons so efficiently that light could travel distances before being absorbed and re-emitted. The glowing fog, filled with energy but impossible to see through. Cosmic dawn. Electrons and atomic nuclei finally combined neutral atoms, allowing light to travel freely for the first time. Cosmic clearing created the afterglow we still see today as the background radiation, a faint echo of creation itself in the corner of the sky. The Big Bang was not an explosion in space itself. It created time as well as matter, the physics that govern everything from quantum fluctuations to galaxies. No event before or since has matched its power to create everything, to establish the very foundations of existence. And yet this cosmic genesis may not represent the ultimate limit of power in our. Beyond the realm of ordinary supernovae lies something far more violent. A star containing 50 times the mass of our sun finally runs out of nuclear. It does not simply collapse and explode. Instead, it nova, an explosion so energetic it dwarfs me by factors of 10 to 100, releasing the energy of atomic bombs detonating every second for millions of years. These stellar even on cosmic timescales, only the most massive stars in the universe, and they must be spinning rapidly when they die. The combination of rotation creates conditions so violent that normal stellar death and fury about to be unleashed. When the core of such a star collapses, it will almost instantly. But the star's rapid rotation, symmetric collapse. Instead, the infalling material disk around the newborn black hole, spinning so fast it becomes generating magnetic fields of unimaginable strength. These twist lines act like springs wound to the breaking point. When they launch jets of matter and energy outward at 9% the speed of light. These jets bore through the collapsing star bits, carrying enough energy to power our sun for billions of years, punch through the star's outer layers and burst into space. Bursts we detect from billions of light years away. But the shockwave from the jet's passage heats the star's interior, those in the cores of normal stars, triggering explosive nuclear burning or remnant. Layer after layer of the star explodes outward thermonuclear violence. Carbon burns to neon, and silicon burns to iron in a matter of seconds. By these rapid fusion reactions adds to the destruction, creating an explosion from the edge of the observable universe. A single hypernova can see elements than dozens of normal supernovae. The extreme conditions isotopes that decay over weeks and months, powering an afterglow after the initial explosion. These cosmic forges produce many for life, scattering them across vast regions of space. The most powerful hypernovae can disrupt star formation across galaxies. Their shock waves compress nearby gas clouds, waves of stellar birth, while simultaneously heating the surrounding medium to tempt further star formation for millions of years. Across hundreds of years of space, two massive galaxy clusters race toward each other thousands of miles per second. Each cluster contains trillions of stars and vast oceans of superheated gas ray light. When these cosmic titans collide, they create events in the universe since the Big Bang itself. Galaxy gravitationally bound structures in the cosmos. The Coma cluster 11,000 galaxies and has a total mass equivalent to 100 trillion suns. When clusters of this magnitude collide, the energy released exceeds all the stars in both clusters by factors of millions. The collision cosmic standards, with the clusters approaching each other over hundreds of millions. Dark matter, which makes up most of each cluster's mass, only the pull of gravity and passes through the collision relatively unaffected. Gas that fills the space between galaxies experiences a very different. As the clusters merge, their gas clouds slam into each other at velocities approaching miles per second. The collision creates shock waves that heat the exceeding 100 million degrees, hot enough to strip electrons from any. The resulting plasma glows brilliantly in X-rays, creating some of the most in the universe. These cosmic crashes can trigger the formation of radiating millions of light years. Magnetic fields stretched and amplified accelerate electrons to near light speed, causing them to emit ray spiral around field lines. The result is a ghostly radio glow of galaxies. The most violent cluster collisions can create bogate outward at thousands of kilometers per second. These cosmic stress and heat the surrounding medium, creating structures visible across vast. The energy contained in these shocks exceeds the total energy out supernovae. During the collision, individual galaxies experience their own violent encounters. Tidal forces can strip the outskirts, creating long streams of stellar debris that trace the natural dance. Some galaxies may be completely disrupted, scattered into the growing cluster's halo. The collision can trigger mass formation, as gas clouds within galaxies are compressed by the encounter. Starbursts can increase a galaxy's star formation rate by factors of creating brilliant blue regions filled with newly born massive stars that will live hidden in the quantum foam that underlies all reality. Stability so terrifying that it could end everything we know in an instant, which gives all particles their mass, might not be in its lowest possible. If this field suddenly dropped to its true minimum, it would create a that expands at light speed, rewriting the laws of physics and in its path. The Higgs field permeates every corner of space, a vacuum between atoms. Like a ball balanced on a hill, currently sit in what physicists call a false vacuum state. But it could potentially roll down to an even lower energy level, fundamental nature of reality itself. If vacuum decay began anywhere, it would create an expanding sphere of true vacuum, moving exactly the speed of light. Nothing could escape this cosmic wave because no information or matter can travel faster than light of its approach until the moment it arrived. Inside the bubble of the fundamental constants of nature would be different. Particles might or might not exist at all. Atoms as we know them could not. The strong nuclear force might be weaker, causing all atomic nuclei to leak. Chemistry and biology would become impossible. Energy difference between the false vacuum and true vacuum would be released as this energy could exceed the rest mass energy of all, making vacuum decay more energetic than converting every proton and electron into pure energy. The universe would be flooded with more star and galaxy combined. Current calculations suggest that our vacuum metastable, balanced precariously on the edge of stability. Events like cosmic ray impacts or black hole evaporation could potentially. Even quantum fluctuations might spontaneously nucleate above empty space. The terrifying aspect of vacuum decay, if the false vacuum state exists. Quantum mechanics guarantee a stable state will eventually decay, even if the probability is incredibly over the vast timescales of cosmic evolution. Even the most becomes certain. Vacuum decay would be the ultimate cosmic. Everything that has ever existed, every star and living being, would be erased and replaced by a universe of different physics. No trace of our current reality would remain, not even the memory that it had ever existed. Some theories suggest it might have occurred multiple times in our universe's history, with each new regions with different physical laws. We might be living in just one, surrounded by realms where the rules of existence are utterly. In the first moments after the Big Bang, when the universe was smaller than an atom core of a neutron star, tiny fluctuations in density form black holes, more massive than mountains, yet smaller than. These primordial black holes would possess gravitational fields so intense in time on scales invisible to the human eye. Unlike black collapsing stars, primordial black holes could have any mass, weigh as little as a paperclip, while others could exceed the mass of our sun. The smallest ones would be quantum objects, where the strange rules of quantum mechanics elude authority of general relativity in ways we barely understand. A hole with the mass of a mountain would be smaller than a proton, yet physical field, millions of times stronger than anything we can create on Earth. Space and time around such objects would be twisted into impossible, creating regions where the familiar concepts of distance and duration. These microscopic monsters would be among the most violent. According to Stephen Hawking's calculations, black radiation can slowly evaporate over time. The smaller the black evaporates, and the more violently it dies. A primordial black large asteroid would explode with the energy of millions of hydrogen bombs. Of a small primordial black hole's life would be spectacular beyond. As it shrinks to subatomic sizes, the rate of evaporation exponentially. In its last second of existence, it would release than our sun produces in an entire year, all concentrated in an atomic nucleus. If primordial black holes exist in large enough to solve one of cosmology's greatest mysteries, the nature of dark matter. Visible objects would exert gravitational influence without emitting light, matching the properties astronomers observe in dark matter throughout the universe. Primordial black holes has led scientists to examine some of the most extreme cosmos. When these objects pass through stars, they would heat and cause detectable changes in brightness. When they collide, they might trigger observable gravitational wave signals. Black holes might have grown over cosmic time by accreting matter and merging with other. These objects could now be lurking in the dark spaces between stars, predators waiting to encounter matter they can devour. Their gravitational might occasionally bend and magnify light from distant stars. Massive primordial black holes could have served as seeds for the supermassive black centers of galaxies today. This would solve the puzzle of how such holes could have formed so early in the universe's history when normal had barely begun. Before the universe was even 1 second old, it underwent the most violent expansion in cosmic history. In a time it takes light to cross a proton, the universe grew from smaller to larger than a grapefruit. This process, called cosmic inflation, the most powerful force ever unleashed, stretching space faster than setting the stage for everything that followed. During inflation, space occurred of at least 10 to the 26th power and just 10 to the negative 35. To put this in perspective, imagine a single atom suddenly in our solar system in less time than it takes light to travel the width of that. This expansion was so rapid it defies human comprehension. The drive inflation was a quantum field called the inflaton, which filled all of energy density. Unlike normal matter, this field had the bizarre more energy as space expanded, acting like a cosmic fuel that never. The more the universe grew, the more energy became available. Expansion. Inflation solved several fundamental problems that had existed for decades. Before inflation, the universe's exotic particles and topological defects that should still be observable today. Expansion stretched these objects to sizes larger than the observable universe, hiding them beyond our cosmic horizon. The expansion during inflation that regions of space that were initially in contact beyond any possibility of communication. This explains why the background radiation has nearly identical temperatures in all directions. Regions could never have exchanged energy after the expansion began. Quantum inflaton field during inflation were stretched to cosmic scales, variations that would later grow into galaxies and galaxy clusters. The ripples in the fabric of spacetime became the seeds of all large stars, from the smallest stars to the largest superclusters. The involved in cosmic inflation was truly staggering. In just a time, the inflaton field released more energy than has been produced by observable universe over the past 13.8 billion years, went into creating new space and filling it with the matter we see today. When inflation finally ended, the inflated into ordinary matter and radiation, reheating the universe to temperature to the 28 degrees. This was hot enough to create and destroy that would make the cores of the most massive stars seem frigidly cold. Some theories suggest that inflation did not occur just once, an eternal process that continues to create new regions of space-time beyond Earth. In this scenario, our entire cosmos might be just one infinite multiverse where new universes are constantly being born through in the heart of a dying star spinning at 1,000 revolutions per second. A trillion times stronger than Earth's, are about to unleash destruction beyond imagination. This is a magnetorotational supernova, where the combination of extreme rotating power creates explosions that dwarf even the mightiest gamma ray, forging magnetic fields so intense they could tear apart atomic nuclei miles away. When the most massive stars in the universe reach the end, some possess magnetic fields comparable to those found on magnetars. Such a star is also rotating rapidly when its core collapses. The constant momentum spins the collapse even faster, like a figure skater pulling a pirouette. As the stellar core shrinks from the size of Earth across, its rotation rate increases by millions of times. Magnetic field lines, frozen into the collapsing plasma, and amplified until they reach strengths that approach this allowed by physics. These fields become so powerful they capture of spacetime itself. The magnetic pressure in these extreme fields leads the pressure inside atomic nuclei. Field lines store enough energy to power our sun for billions of years. Magnetic structures finally become unstable and reconnect. They release this stored magnetic explosions that make solar flares seem like gentle breezes. Of rapid rotation and extreme magnetic fields creates a cosmic more powerful than anything else in the universe. Charged particles caught in these accelerated to energies far exceeding anything achievable in our most advanced. Individual protons gain enough energy to split atomic magnetic impact. These magnetorotational explosions can launch plasma at velocities approaching the speed of light. Unlike ordinary gamma ray bursts, these magnetically driven outflows may cross intergalactic distances, creating beams of destruction planets from millions of light years away. The magnetic fields generate explosions are so strong they affect the vacuum of space itself. Exceeding 10 to the 15th Gauss, the quantum vacuum becomes splitting light into separate polarizations and creating optical effects in the universe. Space itself becomes a kind of cosmic crystal properties. Matter exposed to these extreme magnetic fields, effects that seem impossible by everyday standards. Atoms become eel-like shapes aligned with the field. The chemical bonds that hold molecules twisted and distorted beyond recognition. Even the fundamental of atoms begin to behave in strange new ways. The energy magnetorotational supernova can exceed that of a normal supernova hundreds. The explosion synthesizes exotic isotopes that can any other conditions, forging elements that exist for mere seconds before deforms. These cosmic alchemical laboratories create materials of nuclear physics. In the vast halos surrounding every galaxy, an invisible substance outweighs all the stars by factor. This dark matter feels gravity but interacts with nothing else, creating a shadow universe that shapes cosmic structure while remaining compliant. But if dark matter particles ever encounter their antimatter, it could unleash explosions that make supernovae look like fireflies. Particles, if they are their own antiparticles, would annihilate completely, converting their entire mass into pure energy according to Einstein's theory. A single kilogram of dark matter undergoing annihilation energy has 21 million tons of explosives, making it the most efficient theoretically possible. In the dense cores of galaxy clusters where radiations reach their peak, these annihilation events could create cascade particles and gamma rays. The energy released would exceed the combined stars in the cluster, creating radiation so intense it could be detected years away. Some theories suggest that dark matter particles could be than ordinary protons and neutrons, potentially containing the hundreds or thousands of hydrogen atoms compressed into a single. When such massive particles annihilate, they would create particle shower energy, producing cascade reactions that generate exotic where else in nature. The annihilation process could create pairs of photon energies millions of times greater than visible light. These gamma rays of dark matter destruction, providing a direct window into the properties of this. The most energetic annihilation events could produce photons approaching the Planck scale, where quantum gravity effects become important. Matter annihilation occurs preferentially in high-density regions, feedback effects that shape the distribution of matter on cosmic scales. East could heat nearby gas, preventing it from collapsing to form new stars. Entire regions of galaxies might be sterilized by the radiation from dark matter in their central regions. In the extreme environment near black holes, densities can reach extraordinary levels. Annihilation rates could contribute significantly to the total energy output. These events have signatures in the form of high-energy neutrinos or gamma-ray flare, the presence of dark matter concentrations. Some theoretical model dark matter annihilation could trigger chain reactions, where the energy relates conditions favorable for further annihilation events. These annihilations could empty entire regions of space of their dark matter content, make voids filled with high-energy radiation. The search for dark matter has led astronomers to examine the most extreme environments in the universe. Galaxy centers, where dark matter densities peak, are prime targets for gamma ray signatures of annihilation. The absence of clear suggests that either dark matter does not self-annihilate, or the process earlier than initially predicted. Somewhere in the depths of space, protons to energies that dwarf anything we can achieve on Earth. These cosmics through the galaxy at 99.9999% the speed of light, carrying individual energies equivalent to a baseball thrown at 60 miles per hour, single atomic nucleus. The cosmic accelerators that create these on scales and with efficiencies that make our most advanced technology seem primitive. Most energetic cosmic rays, detected on Earth, carry energies exceeding electron volts, more than 10 million times the energy achievable by light. A single one of these particles contains enough energy to light a brief moment, all concentrated in an object smaller than a proton. Particles strike Earth's atmosphere. They create cascades of secondary particle vectors spread across thousands of square miles. The cosmic accelerator responsible for these extreme particles remain one of astrophysics. Supernova shock waves can accelerate particles to high energy, cannot explain the most extreme cosmic rays. The electric field accelerate particles to such energies would need to extend across distant light years and maintain voltages exceeding 10 to the 20 volts. If galactic nuclei powered by supermassive black holes present the most likely cosmic accelerators. The magnetic fields store enormous amounts of energy, releasing it in sudden bursts that accelerate relativistic speeds. The jets launched by these black holes create accelerators, millions of light years long, far exceeding any human-built machine. When cosmic ray particles travel through magnetic fields in space, they are different, making it nearly impossible to trace them back to their sources. Magnetic particles, those with energies exceeding 10 to the 19th electron, travel in nearly straight lines through galactic magnetic fields. These particles provide our only direct probes of the most extreme acceleration process. The interaction of cosmic rays with magnetic fields, spectacular phenomena in astrophysics. When these particles spines, they emit synchrotron radiation that glows across the spectrum. The radio emission from our galaxy is largely produced by electrons, spiraling through the Milky Way's magnetic field. Acceleration can occur through multiple mechanisms, each operating on different scales with different energy spectra. Shockwave acceleration occurs when they cross shock fronts, gaining energy with each crossing. Magnetic accelerate particles impulsively when twisted field lines suddenly split themselves. The most extreme cosmic ray events might different acceleration mechanisms that we have not yet discovered. Suggest that the decay of exotic particles left over from the Big Bang rays, with energies exceeding anything possible through conventional acceleration. These hypothetical particles could be relics of physics beyond the standard model. Cosmic ray interactions with gas and dust in space create including gamma rays, neutrinos, and positrons. Products carry information about both the cosmic rays themselves and the environment. The study of cosmic ray secondaries has revealed the composition of stellar medium in ways impossible through direct observation. The empty space between atoms, between planets, between stars, vacuum seethes with invisible activity. Virtual particles and annihilate each other in time so brief they exist below the observation. Yet, these quantum fluctuations, smallest possible scales, contain enough energy to power the entire universe and may ultimately determine the fate of reality itself. Vacuum is not truly empty, but filled with zero-point energy that exhibits absolute zero temperature. Every cubic centimeter of spatial photons, electron-positron pairs, and count combinations that borrow energy from the vacuum and must pay. Quantum mechanics notices the violation. This constant creation of virtual particles creates an energy density that, if it could be, would exceed the mass energy of all matter in the universe. Calculate the energy density of quantum vacuum fluctuations should be 10 to the 100 larger than the observed energy density of the universe. This enormous, known as the cosmological constant problem, represents failures of theoretical physics. If these calculations were correct, itself would be so energetically unstable that atoms could not exist. Fluctuations do produce measurable effects that confirm their reality. The mere effect demonstrates that two metal plates placed very close together will be by the pressure of virtual particles. The space between the plates is wavelengths of virtual photons, creating an imbalance that generates detectable force. Virtual particles near the event horizons have become real through a process discovered by Stephen Hawking. One member particle pair can fall into the black hole while the other escapes the black hole to slowly evaporate. This Hawking radiation represents vacuum energy into real particles, demonstrating the tremendous power of fluctuations. In the early universe, quantum vacuum fluctuated to cosmic scales during the period of inflation. These microscopics became the seeds of all large-scale structure, growing under the influence form the galaxies and galaxy clusters we observe today. Every living being owes its existence to quantum fluctuations that occurred when the universe atom. Some theories suggest that our entire universe originated in vacuum fluctuation, a brief deviation from nothingness that's in. In this scenario, the Big Bang itself was not the beginning of time when a virtual universe became real, borrowing energy, quantum vacuum that it has been repaying ever since through cosmic expansion. Power contained within quantum vacuum fluctuations might be accessible through it that could manipulate the structure of spacetime itself. Theoretical vacuum energy involve creating negative energy densities, boundary conditions that determine which virtual particles can exist in a given. If vacuum energy could be harnessed, it would provide an infinite source of power that exists everywhere in the universe. A device hub could potentially extract enough energy to power human civilization for making all other energy sources obsolete overnight. Beyond the universe, beyond the most distant galaxies we can ever, lies something that dwarfs all the cosmic forces we have encountered. The multiverse exists. Our entire universe, with all its black holes and gamma-ray bursts, becomes nothing more than an infinite ocean of realities, each with its own laws of physics and its own ultimate fate. In the eternal inflation scenario, our Big Bang was not a unique event, but one of countless and continuously throughout higher dimensional space. New instantly being born as quantum fluctuations trigger inflation in regions of creating an ever-expanding tree of cosmic domains that stretches infinitely. Each universe within this multiverse could have completely different fundamentals. In some, gravity might be stronger or weaker, stars and galaxies. In others, the electromagnetic force making atoms impossible or creating matter with properties we can. The strong nuclear force could be altered, preventing nuclear fusion elements that cannot exist in our reality. The total energy content multiverse would literally be infinite, making it the ultimate expression of cosmos. Every possible configuration of matter and energy, every potential history would exist somewhere within this vast realities. The power to create infinite universes with infinite represents the absolute pinnacle of cosmic force. Some regions contain universes that expand forever, while others collapse back on themselves that mirror their Big Bang origins. Still others might oscillate in contraction, creating cyclic cosmologies that repeat endlessly. A variety of cosmic destinies within a multiverse would encompass every allowed by mathematics and physics. In certain interpretations, the multiverse consists of all possible outcomes of quantum measurement simultaneously in parallel realities. Every time a quantum multiple possible results, the universe splits into separate branches containing a different outcome. This quantum multiverse would be constantly as new possibilities are realized. The anthropic principle observe our universe's particular combination of physical constants. Combination allows observers like us to exist. In all possible combinations of physical laws, conscious beings would nest in universes capable of supporting consciousness, no matter how unlike it might be. If communication between different universes were possible, access to unlimited knowledge and resources. Technologies developed different physics might be incomprehensible by our standards, but could offer problems we cannot even imagine. The exchange of information across the multiverse represent the ultimate expansion of scientific knowledge. The ultiverse might involve the consumption of false vacuum regions by expanding bubble, creating a cosmic selection process where only the most stable survive in the long term. This could lead to a final state where all of reason on a single set of physical laws, ending the infinite diversity of the multiverse. We have journeyed from the quantum realm to the infinite multiverse, that stretch the very limits of what reality can contain. From force binding atoms together, to the possibility of infinite universe destroying themselves without end, we have seen power expressed on every concept. The most remarkable truth we have discovered is that the universe does not stop, it is power. Every atom in your body exists because formation hold it together. Every star that lights the cosmic darkness, nuclear forces convert matter into pure energy. Every galaxy, because gravity and dark energy wage their eternal war of light years. But perhaps the most profound realization is that we observers are not separate from these cosmic forces. We are there. The calcium in our bones was forged in stellar explosions. Iron in our blood was scattered by dying stars. The gold in our created when neutron stars collided in violent embraces that shook spacetime. We are literally made of stardust, assembled by forces so powerful they destroy entire worlds. Yet here we stand, conscious, capable of contemplating our own cosmic origins. Proof that the power may not be its ability to destroy, but its capacity, beauty, and ultimately, awareness of the universe has been working for 13.8 billion years to create for you to exist. Every force we have explored, fluctuations to galactic collisions, played a role in bringing about this moment and your place in the cosmic story. What is the most powerful thing in the universe? Perhaps it is not any single force, but the universe's inexhaustible, its ability to transform simple hydrogen into stars, elements into planets, and planets into the stage where life emerged to contemplate the very forces that brought them into being. Up at the night sky, remember that you are witnessing the ongoing battle battles that have shaped everything you see. And remember that you, ashes and quantum dreams, are not just an observer of this cosmos, you are one of its greatest achievements. The universe's most ultimately be its capacity to know itself through beings like us. Cosmic power. We become the universe awakening to its own magnificence than the full moon. Even from galaxies billions of light years, the energy released in seconds exceeds what 10 trillion hydrogens if they exploded every second for the entire age of the universe. The most powerful gamma ray burst ever detected, nicknamed the of all time, occurred in October 2022. That it saturated gamma ray detectors across the solar system and changes in Earth's upper atmosphere from a distance of 2 billion light. Picture standing on Earth and watching a flashlight beam from Alpha Centauri as a car headlight. That gives you a sense of how impossibly truly are. The light we detect traveled for billions of years, stellar deaths from when the universe was young and stars were more massive than we see today. Scientists have detected bursts so distant and traveling when the first stars were being born, less than 1 billion years. These ancient beacons give us glimpses of the early cosmos. Stars lived fast and died violently, seeding space with heavy elements. Later generations of stars and planets.